All right, let's dive right into this explainer. Today, we're looking at the ultimate blueprint for an eco-friendly smartwatch, literally from cradle to cradle. We live in an era where wearables are evolving from just simple step counters into these highly connected medical hubs. But as they become so totally indispensable to our daily lives, we've got to pause and ask, how are they actually built? And what do they leave behind? So we aren't just looking at the specs of some new gadget today. We're unpacking a blueprint for the ideal, sustainable device. We're going to trace the chronological journey of this device through 5 critical phases: sourcing ethical materials, engineering modular designs, integrating micro LEDs and sensors, programming privacy, and finally, end-of-life planning. Let's get to it. So, why does this even matter? Well, just think about the staggering 53 million metric tons of e-waste we generate globally every single year. It's an almost incomprehensible number. To put that in perspective, a study from MIT noted that a single conventional smartwatch emits about 34 kilograms of CO2 just during its production. And get this, up to 75% of its materials are completely non-recyclable. When you consider that wearable device shipments are projected to blow past 500 million units annually by 2027, the environmental cost of the status quo is, well, it's simply unsustainable. So, this step-by-step blueprint is going to guide us through exactly how the industry can actively fight that massive e-waste problem. It outlines a device that pushes the absolute boundaries of 5G connectivity and AI, but does so with a profound respect for our planet and our personal autonomy. Section 1. Sourcing ethical materials. Because honestly, before a single line of code is even written, a product's footprint is heavily determined by what we literally pull out of the earth to make it. It's wild to see the stark contrast here between the old paradigm of toxic, energy-heavy materials and this new wave of sustainable alternatives. Traditional manufacturing leans so heavily on virgin aluminum, which requires massive amounts of energy. Instead, this blueprint utilizes 100% recycled aluminum, instantly cutting the energy required for the casing by 75%. And my absolute favorite part? Swapping out petroleum-based plastics for mycelium composites, literally growing materials from mushroom roots, and using plant-based silicone derived from sugarcane for the straps. It's just brilliant. And taking a major cue from Fairphone's supply chain, we see that internal electronics can rely on conflict-free minerals and fair trade certified components. The internal circuitry of any smartwatch requires super precise metals, but by insisting on fair-mined certified gold and conflict-free tungsten from tightly regulated sources in Rwanda, the blueprint proves that the tech on our wrists doesn't have to fund armed conflict or exploit labor. It's all about building a genuinely ethical foundation. Moving right along to Section 2, engineering modular designs. Let's see how those ethically sourced materials actually build into the physical architecture of the watch. The Unawatch perfectly models this approach to ending planned obsolescence. In an industry that's notoriously criticized for sealed, disposable units completely glued together with toxic adhesives, modularity is a massive breath of fresh air. Imagine your battery starts losing its charge after a couple of years. Instead of throwing the whole watch away, you simply use standardized screws or even tool-free snap-in mechanisms to just pop out the old battery and click in a new one. Plus, with open-source repair manuals, the power of maintenance is put directly back into the consumer's hands. And the impact of this? Absolutely massive. Implementing this kind of modular, repairable design bumps up the product's lifespan by an incredible 70%, and it lowers the total cost of ownership by half. When you can easily upgrade a specific health sensor to the latest model without buying a brand new watch, you drastically cut down on electronic waste. Okay, Section 3, integrating micro-LED and sensors. With our modular chassis completely built, it's time to light it up and power the whole shebang with next-generation hardware. While OLED has definitely been the standard for a while, micro-LED is totally poised to revolutionize wearables. It offers superior outdoor brightness and allows sensors to be placed directly beneath the display. OLED is great, sure, but to push efficiency further, manufacturers are using complex stacked structures that actually slow down production and raise costs. Micro-LED completely changes the game. It is incredibly bright without suffering from that dreaded burn-in effect. And what's even more revolutionary is that micro-LED allows manufacturers to integrate optical sensors right under the display itself, saving precious physical real estate inside the watch casing. Just look at the power efficiency. Micro-LED technology is evolving to consume literally half the power of advanced OLEDs, which is a huge win for battery life. At a peak brightness of 1500 nits, an advanced OLED might draw about 180 milliwatts, but micro-LED literally cuts that power draw in half. And it's simple math, right? When your screen uses less power, you don't need to charge as often, reducing the overall wear and tear on your battery.
And to power that super efficient display, the Blueprint transitions away from your traditional lithium-ion batteries. We already know companies like Samsung are making huge strides towards mass-producing ultra-small solid-state batteries for wearables, and this tech is vastly superior. A standard lithium-ion battery might give you 500 charge cycles before degrading. Solid-state doubles that. In graphene, it could theoretically hit an astonishing 10,000 charge cycles. Longer-lasting batteries mean fewer replacements, which perfectly aligns with our whole eco-friendly mission here.
Now, to handle the device's AI and all that continuous health monitoring without absolutely tanking the battery, we're talking about using a hyper-efficient 3-nanometer processor, something like the Exynos W1000. Future wearables aren't just counting steps anymore. They are continuously monitoring blood pressure, like we're seeing with the Huawei Watch G2, predicting fainting spells and processing complex on-device AI. Shrinking the silicon down to a 3-nanometer architecture allows for smartphone-grade processing power right on your wrist, optimizing power consumption in real time so your watch can think faster and last much longer.
All right, Section 4, Programming, Privacy, and Autonomy. Now that the hardware is fully integrated, we've got to talk software. Specifically, how we protect the incredibly intimate biological data this thing is going to collect.
Right now, there's a pretty alarming power asymmetry in consumer wearables. Basically, your data is often being fed straight into black box algorithms and to third-party marketers. As researched by Dr. Marielle Gross, the traditional model extracts your biological and geolocation data, feeds it into proprietary systems to teach AI, and often nudges your behavior without any real transparency. A genuinely sustainable smartwatch has to flip this dynamic entirely, ensuring that you, the user, not the manufacturer, actually own your highly sensitive health metrics.
So, to ensure absolute data autonomy for you, the user, our ideal smartwatch is going to employ cryptographic solutions like zero-knowledge proofs. These verify data without ever exposing the underlying personal secrets. Think about it. Your watch can confirm to an app that your heart rate is within a healthy range for a fitness challenge without ever transmitting your actual heart rate data to a server. Combining this with hardware-based trusted execution environments means your biological data is encrypted and locked away, totally safe from prying eyes and data brokers. And finally, Section 5, Planning for End of Life. Because the true test of any eco-friendly product is what happens when it's just no longer useful to us. By actually designing for end of life right from the jump, we can use techniques like bioleaching and robot-assisted disassembly to recover a staggering 97% of the watch's materials. Because it's built modularly with standardized screws and tool-free snaps, taking it apart is incredibly simple. Specialized robots, similar to what Apple uses for iPhones, can rapidly disassemble the unit. Then, cutting-edge biological processes like enzymatic plastic breakdown and bioleaching allow us to naturally recover the valuable metals and composites without resorting to toxic smelting. Ultimately, though, this whole thing requires a massive shift away from the old buy and discard model, moving toward circular business models. We're talking deposit returns and upgrade leasing. Imagine paying a deposit when you buy the watch, which you get right back when you return it for recycling, or an upgrade lease where you basically subscribe to the hardware. When you want the new model, the company takes back your old one, refurbishes the modular parts, and deploys them into a secondary market. It makes sustainability highly profitable and frankly super practical. As we wrap up this explainer, I really want you to take a second, look at your own devices, and ask yourself, are they built for the future of our planet, or are they just destined for the landfill? We have the technology right now, from ethically sourced mycelium straps and repairable modular designs to hyper-efficient micro-LED screens and zero-knowledge privacy protocols. The blueprint for a truly sustainable smartwatch already exists. The only question now is which manufacturer is going to be bold enough to bring the ultimate eco-friendly wearable to the market first. Keep an eye on your wrists, folks.